Hello everyone, and welcome to the ninth tutorial in our series. In the previous lesson, we looked further into tables and we learned the differences between arrays and dictionaries. In this lesson, we'll start to see the importance of tables and their prevalence all throughout Luau by looking at built-in libraries such as the math and table libraries. A library is just a built-in set of functions. For example, the math library, as the name suggests, is a set of functions related to math. There is also a table library, which contains functions related to tables, such as manipulating them. There is also a string library, which contains functions related to strings. However, since the string library can be very complicated, I'll make a separate series dedicated to it in the future. Besides the math, table, and string libraries, there are many other libraries built into Luau which we'll learn as we go along. Today, we'll just look into the math and table libraries. The math library, as mentioned before, contains many functions related to math. For example, the math library has a function which generates a random number. Let's see how that works. To use a function from a library, we start with the name of the library we want to use, so math, and then we follow it with a dot or period, and a drop-down box should appear next to it showing all of the available functions in the library. Next, we write the name of the function we want to use. The name of the random number function is random in all lowercase letters, so we will write random next to the dot, and add parentheses to call the function. And the random function can take two numbers as arguments. The first number sets the minimum for what the random number can be, and the second number sets the maximum. We can set the minimum to 1 and the maximum to 100, and the function will generate a random number between these two. But before we test the code, let's make sure to capture the result in a variable and print it. And this is how we use libraries and their functions. You might have already noticed that this part, math.random, is exactly like how we index keys in a dictionary. We write the name of the table, follow with a dot, and then the string key of the value we want to access. If you don't remember how tables and string keys work, I suggest looking back at the previous lesson where I discussed tables and dictionaries in more detail. The reason for this similarity between how we access functions in a library and how we index string keys in a table is because all of these built-in libraries are actually tables themselves. If you print a library, it will show a table in the output with all of its keys and values. Some of the other functions in the math library include a square root function, which I like to call math.sqrt. There is also a function that returns the absolute value of a number, math.abs. And if you don't know what absolute value means, you can think of it as the distance between a number and 0 on a number line. So the distance between -5 and 0 is 5, and the distance between +5 and 0 is also 5. The math library also hosts some rounding functions for decimals. For example, we have math.round, which rounds down any decimal that is less than 0.5 to 0, and rounds up any decimal that is 0.5 or higher to 1. We also have math.floor, which rounds down all decimals to 0, and math.ceil, which rounds up all decimals to 1. The math library also contains functions that find the highest number or the lowest number in a given set. For example, math.min finds the lowest number from amongst the numbers you pass to it, and math.max finds the highest number. The library also has a function called math.clamp, which limits a number between a minimum and a maximum. If a number is within these limits, the function simply returns the same number back to you. However, if the number is greater than the maximum, it returns the maximum number instead. Likewise, if the number is lesser than the minimum, it returns the minimum number instead. And there are many other functions in the math library that you can check out. I'll leave a link to its documentation in the video's description. But besides functions, the math library has two constants available, math.pi and math.huge. Math.pi is simply the value of pi. And as for math.huge, you can think of it as infinity. Any number will always be less when compared with math.huge. Likewise, any number will be large when compared with negative math.huge, and we'll see why these values are important in our upcoming lessons. Now let's look at the table library. It has some functions that only work with arrays and others that work with any table. For example, table.find looks for a specific value in an array and returns its key or index if that value exists in the array. This is useful when you are looking for a specific value in an array and you don't know its index. And if the value repeats in the array, table.find returns the first match. But table.find has an optional third argument that lets you specify which index to start the search from. So you can make the function start from the third index to find the second b. The next function we'll look at is table.insert. Table.insert inserts a value in an array to a specified index. The function can take three arguments. The first one is the array in which you want to insert the new value. The second argument is the index. Which index do you want to insert the new value in? And the third argument is the value you want to add to the array. If a value already exists at that index, to make space for the new value, the function shifts the existing value up to the next index, along with any values that come after it in the table. And if you don't specify which index to insert the new value in, the function will simply insert it at the end of the array. And if you remember from the previous lesson, I gave an assignment to create a function that lets you insert values to the end of an array. If you managed to do it, how would you change your code now to make it work similarly to table.insert? Now moving on to the next function, table.remove removes the value from a specific index in an array, and it shifts down any following values to the previous index. The function takes two arguments. The first is the table you want to work with, and the second argument is the index you want to empty from the table. The function also returns the value it removed from the table, so we can capture that and print it. And again, if you don't specify which index to remove, the function will empty the last index of the array. Table.insert and table.remove both function differently to the methods we have used so far for adding and removing values from tables. Normally, when we want to add a new value to a table, we index the table's key and assign it to the new value. However, if that key was already occupied by a different value, this action will overwrite it, and we will lose that previous value from the table. Imagine we are working with a table of real players. We could potentially lose track of a player and break the game. Table.insert works differently to this because if it sees that the key is already occupied by a value, it will shift that value and all the values that come after it to their next keys, and then it will add the new value to the correct key. And when table.remove empties an index from an array, it shifts all the following values down to their previous index. This ensures that there are no gaps left in the array when you remove a value. The final function we'll look at is table.sort. Table.sort allows you to rearrange the values in an array into many different orders. The function can take two arguments. The first is the array you want to rearrange, and the second argument is a function which determines the new order of the values in the array. Let's say we want to rearrange this array so that the values are ordered from largest to smallest. To do that, we firstly pass the array to table.sort, and then we pass our sorting function. In fact, we can create the sorting function in this line without having to assign it to a variable. And any function created like this is called an anonymous function because it is not linked with any name or variable. It's anonymous. This function that we pass to table.sort receives two parameters, which are any two values from the array. We can call these parameters a and b, and the function must compare these two and return a boolean, true or false, so that table.sort knows how to rearrange the values in the array. Since we want to reorder the values in descending order, we want to make sure that the first value, a, is always greater than the next value, b. Now table.sort knows how to rearrange the array. But let's say we want to reorder the values in ascending order instead, so they go from smallest to largest. all we have to do is edit our sorting function so it ensures that the first value is always lesser than the next value. And in this way, we can rearrange an array into many different orders. For example, we could have an array of strings, and we could order the strings so that those with the least amount of characters come before those with the most amount. The way we can do that is by comparing the lengths of the strings. When we use the hash operator on a string, just like with arrays, it tells us the string's length. So it tells us how many characters or letters are in this string. And now we can order the strings so that those with the least amount of characters come before those with the most amount. And if you don't pass a sorting function to table.sort, it will attempt to sort the array's values in ascending order. But that will only work if the values in the array are all numbers. There are many other functions in the table library too. I'll add a link to its documentation in the video's description so you can check them out. Overall, libraries are very useful tools for scripters because they provide pre-written functions that can be used in multiple scripts and projects, saving scripters a lot of time and effort. Instead of trying to reinvent the wheel, you can use these libraries to perform common tasks and use your time for scripting a lot more efficiently. But don't worry, you don't have to memorize all of the functions. It's better to learn each one when you need it. As for an assignment, you can try to create your own function library that works similarly to the libraries we've looked at today. So to use a function in your library, you write the name of your library and index it with the name of a function. And for a second assignment, create an array where all the values are the same, and you change one of its keys at random to hold a new value. Now only using the table library, find the intruding value and remove it. I'll add my own solutions to these in the description too. And again, thank you all for watching. I'll see you in the next one.